Welcome everyone. Thank you for joining us for today's session, Composites Design and Manufacturing Technology Assimilation for the RACER Rotorcraft. I'm Jim Sherman. I'm the Director of Strategic Development here at the Vertical Flight Society. And for today's program, we have two members of the Clean Sky 2 RACER program to talk about the advanced composites they're using in the project. So a little housekeeping before we get started. If you have some questions during the presentation, please type them into the chat/question box in your GoToWebinar control panel, and we'll address those questions at the end of the presentation. So now let's go ahead and get started. So first, I have lost what I was looking for. Here we go. Our first presenter is Katrin Mayrhofer. She's a program manager at INCAS. Katrin joined INCAS in July of 2017 as a program manager for the Romanian Consortium Rotorcraft of the RACER project. Her main responsibilities are the planning, monitoring, and coordination of all technical related tasks. Katrin previously worked for Airbus Helicopters as PMO within the RACER program, being involved since the beginning of the project, and was responsible for program management support of all stakeholders, internal, external, and customers. And our second presenter is Arnau Cubillo of Romaero. He is the coordinator for the composites manufacturing activities for the RACER project at Romaero. He works in the R&D department since 2018 and is an expert in composites manufacturing and is responsible for the management of all composites related R&D projects of Romaero and the associated technology development and assimilation. And we'll say that he also spent most of last night in the lab. So he's bright-eyed, bushy-tailed, but I don't know how he's done that. So with that, I'm going to go ahead and turn it over to you, Katrin, and we'll go ahead and get started.
Thank you, Jim, for the introduction, and welcome everybody. Just when we prepared the presentation for the webinar, for the technical talk, I remembered slightly why I started this journey going to Romania, leaving Airbus. And I was looking for a new challenge and developing myself a bit more and my knowledge. And I can tell you, I got a lot of challenges in here. So I'm very, very glad to be here today and to tell you a bit about what we are doing. Can we probably get the next slide? So as Jim said, I started working here at a research institute for aerospace in Bucharest. So we are a public founded body and we have a quite long history in aerospace research, more than 65 years already. And yeah, we are doing, of course, more than the RACER, but currently the RACER is one of our biggest programs. Within the institute, we are responsible for the airframe design and all stress-related topics, which is really challenging because you can imagine that as a research institute, you have scientific people, and the most of them don't have the practical experience of manufacturing or assembly, so it's quite challenging even for the designers. And yeah, our full expertise is a wide range. We have plenty of wind channels as well, and we have a lot of experience also within European research projects like the Clean Sky Blade. It was Clean Sky 1. We are a member of REA, CARE, and IFAR, and we are participating in the Flight Path 2050 for European projects. So I will hand over to Albert now to introduce Romaero a bit.
Thanks, Katrin. And I would first of all take the opportunity to thank Jim for this opportunity of taking this webinar. As Jim mentioned, I'm Albert Arnau. I'm the responsible for composites manufacturing for the RACER project here in Romaero. And let me start with a brief introduction on what is the company, on what we do at Romaero. Basically, we are the third largest manufacturing company in the aerospace field in Romania. We are divided primarily into commercial activities. The first is structures manufacturing, and the second one is aircraft repair and overhaul. We are one of the oldest companies in the aerospace industry in Romania, active since 1920. And since then, we've been always public-private combination. The state-owned private company, due to the strategic fields in which we are involved in. We work for commercial partners like Airbus, Boeing, Embraer in the manufacturing of parts and sub-assemblies. But we also work on the military side with primary Romanian contractors, either on logistical support, either on manufacturing capabilities. Basically, Romaero has an extensive, and I will enter in this part of the presentation, focusing on the manufacturing capabilities of the company. We are specialized in metallic manufacturing mostly. And the capabilities that we have focused both on sheet metal manufacturing for aluminum parts and for CNC milling and machining of also mostly aluminum parts. We provide the complete capability from A to Z on what it means aluminum manufacturing, which means that we also have capability for surface treatment, painting, and inspection. And last but not least, and it's one of the key points of what we will see later on in this presentation, is the capacity for tooling design and manufacturing. We have a significantly large tooling workshop for the size of the company, which has the capability of designing and manufacturing all the tools that we later on use in our manufacturing processes, on our assembly processes, or also as a final product to other clients which we have in this field. So if Katrin, can you tell us a bit more on the RACER project?
Yes, maybe we can go to the next slide, please. So yeah, the RACER program is a joint European funded project, which is running under the umbrella of Clean Sky 2. And the aim of the program for the FRC was to develop the new VTOL formula in order to fulfill the mobility gap between conventional helicopters and airplanes. And I think we're quite on a good way with that. The overall project is developed under the coordination of Airbus Helicopters Group within a European partnership, as mentioned. So within the RACER, we are the Romanian consortium, which is Romaero and INCAS, and INCAS is the consortium leader for it. And as mentioned, we are doing the advanced airframe design and all the stress topics, and also 2 physical static tests for the airframe. And the project goes up to a TRL level 6, which means we go really into flight tests. And it's a quite interesting project. I would say a once in a lifetime project, probably, where we are participating, and it's really fancy and interesting. So maybe we can go to the next slide, please. So the RACER Demonstrator will be a medium class rotorcraft with a cruise speed of 220 knots. I think it's already well known, as we are publishing more and more what RACER is about. And the implementation of the open architecture allows us a great variety of missions, equipment, and ease the configuration modification without significant impact on the main structure. The standard interfaces and the smart arrangement for plug-and-play potential is also allowing us to speed up the upgrading of the system with new capabilities. The envisioned missions are, with this helicopter, possible for VIP transportation, oil platform services, emergency medical services, and search and rescue missions. Can we please get the next slide? So the Romanian consortium is, as I mentioned already, responsible for the center fuselage design and manufacturing, what happens in Romaero. So we design the center fuselage, we do the manufacturing within Romaero and of course other partners where we outsource some topics, and Romaero is also doing the assembly, tooling, design and manufacturing. The component manufacturing and the assembly is happening here. The stress specimens are designed in INCAS and manufactured as well here in Romaero. The testing will happen within Straero. It's an INCAS subsidiary within our institute, and we have a testing facility there. And there we will do 2 stress tests. Static tests are foreseen currently. If needed, we will do fatigue tests. Therefore, we're going to cut the fuselage into 2 parts, so we will not have the static test in a full fuselage setup. So we will perform an upper deck test, and we will perform a wings step test for the lower part. And of course, we are also responsible for the quality acceptance for the permit to flight, to deliver everything according to the rules to Airbus in order to get the permit to flight done. The challenges within the consortium, we decided to say mostly everything. It sounds a bit harsh, but yes, it's reality. The most of us are not used to work in such an environment. Romaero is used to work in a serial production or maintenance mode, and as I said, the combination of everything is just very challenging every day, but so far we're doing okay. Maybe we can go to the next slide, please, which Albert will tell you a bit more about the aspects of the innovation for the consortium.
Yes, thank you, Katrin. This is mostly what you were saying also. The innovation in this project within this consortium is one of the main challenges. We are basically doing not necessarily new things in all the aspects of what we're doing, but we are certainly doing everything in a different way from which we are used to. As you mentioned, Katrin, we are used at Romaero on a serial production basis. We are working most commonly on a build-to-print basis, and we find in this project, first of all, that the development of a demonstrator from within the consortium that is developing a significant part of this demonstrator means an atmosphere of constant change, which means that we are we are manufacturing things for which the design is constantly changing up to the point in which the part is manufactured, and then even later on. So we find ourselves in most cases with parts manufactured which are already obsolete and for which we need to do retrofits due to this ever-changing nature of this demonstrator. We are pushing a lot what it means, our way of working in several aspects, which are mostly the design of hybrid structures on the design point of view, which means combining the composite panels that integrate the fuselage of the RACER helicopter with the aluminum substructure. This is an element of innovation for INCAS and for us Romaero on assembly later on, which poses a lot of challenges also in what it means assembly of these hybrid structures. we start encountering problems which we are not that experienced on. Working with aluminum all the time, there is no such thing as electrical bonding problems. There is significant challenges in this aspect in this RACER demonstrator, as we are working with all the fuselage skins being composite. As we are talking about composites, for us, composite manufacturing technologies is an element of innovation which we are developing within our R&D facility at Romaero, and for which later on in the presentation we will see the considerations for industrialization. As for all the R&D programs, we are aiming at the know-how development within the facilities. We want to develop internal capabilities, and we want at the end of the project to be able to exploit these capabilities for commercial purposes, for whichever other projects that we find convenient at the moment. This imposes challenges also in terms of process qualification. We need to certify all these new processes, which at this RACER stage are going to be certified for a demonstrator, which means that we will not always get the certification on an ISO basis. We will just get approved by Airbus as the beneficiary of our product in order to obtain the permit to fly for the helicopter. If we would be talking about an industrial phase, this would not be possible, and then we would be talking about a way more extensive process of certificating the different manufacturing processes. And last but not least, as also Katrin mentioned, the tooling manufacturing for composites, it's challenging, as we have no internal experience right now on tooling for manufacturing of composite parts, of course, as our manufacturing capabilities are primarily metallic. Everything what it means to manufacture tools for composites is an added degree of complexity and for innovation. We just included two pictures in here. One, they are both toolings for composite parts for the RACER, and we are working primarily, we will see later on in a bit, with two different technologies of toolings. We're working with metallic tools, we're working with composite tools. This imposes challenges. In each of the fields, we are encountering tons of problems which we did not foresee at the beginning, which we need to correct on the way, which we need to overcome, which we need to adjust to. And this is what makes this project this interesting. And this is why this project is keeping us awake all these nights. If we could go to the next slide, please. In terms of the composite technologies that we are developing, we need, first of all, to make clear, because we do not want a misunderstanding in this area, most of the elements of innovation that we are integrating in this project are elements of innovation for our consortium, for our two companies, for INCAS and for Romaero, which do not make these technologies necessary top of the spear at every moment for every aspect. We are using technologies at the state-of-the-art level, but we are not pushing in this project the research on new materials or new manufacturing technologies for composites. It's not the scope of the problem of the project, and it is important in a big project like this to keep the definition on what are the areas of innovation under control, because otherwise the problem gets easily out of control in terms of the area of development, and we would encounter a situation in which it would be nearly impossible to complete the project. So the areas of innovation in terms of composite technologies are related mostly only within the consortium. And we are talking about two main capabilities. We are talking first of all on the manufacturing capabilities for monolithic components and also for sandwich technologies. In the picture that we included on the top right corner, you can see one of the first RACER components to come out of the shop, which is already a monolithic and sandwich component with reinforcements. The way in which we are developing these capabilities for this project basically include all the manufacturing line for composite parts from A to Z almost, which means that we start first of all with the facilities required for composite material handling and storage, which means freezer, refrigerator for minus 18 degrees storage of the prepregs that we are using, and for the rest of the materials that require refrigerated conditions. We are also talking about nesting and trimming capabilities for the prepregs. We are talking about laser-aided layup for the different parts on the toolings. We're talking about autoclave curing processes. We're talking about drilling and trimming of the parts. And we're talking about the inspection and quality acceptance protocols for these parts. There is, if we were to say a percentage, 70 to 80% innovation in all these processes within INCAS and Romaero. And we're pushing very hard for these processes to be approved by Airbus for the Demonstrator. At this moment, we are almost completed with the certification of the composite parts, which is a significant milestone. And we are confident that by the end of the project, we will have these technologies mastered at the level that this project required. If we could go to the next slide, please. In terms not only of composite component manufacturing, but also on general manufacturing challenges within this demonstrator, we would be talking, as we already mentioned before, first of all, on the tooling aspects. It is very important, as the design in a demonstrator will be always defined at a very late stage on the development of the project, to find a compromise between the design information that is already frozen, so we can start advancing at least on the tooling manufacturing, on the tooling design and manufacturing, and also on the assembly tooling design and manufacturing. You can see, for example, on the left picture, the main assembly jig for the center fuselage for this project. In this picture, it was not 100% completed. It was at about the 90% stage. And this tooling is, this assembly jig is quite complex for such a size of a vehicle, which means that it takes a lot of time to design and it takes a significant amount of time to manufacture, which means that we cannot afford completing the design and then start the production process. It is very important to define what we took as a tooling data drop approach, in which some of the aspects related to the tooling design are frozen out of each single part, each single component, and each single assembly. So we can just compress the whole schedule and feed the manufacturing of the tooling. Secondly, it is very important to define at a very early stage a build philosophy. A build philosophy will allow for the assembly sequence to be under control at every time. At any moment in the project, we will know which are the critical path elements, and we will be able to define which are the areas in the design and manufacturing in which we need to focus in order to keep the schedule under control. Also related to this, it was very important, mostly on the early stages of the manufacturing of the helicopter, to control everything that was tagged as a long lead term item. It was very important for demonstrator level to consider that the availability of the materials, the availability of the subcontracting capabilities, the availability of the internal production capabilities are not unlimited and are not immediate, which means that for some of the aspects, we are going to have a very long lead time when we are comparing it to the whole assembly and whole manufacturing timeline of the helicopter. defining these elements at a very early stage on the manufacturing and on the procurement process allowed to compress significantly this stage of the development of the helicopter. And in terms of manufacturing challenges, it is always relevant to talk a bit about risks. We always work with risks in absolutely any project, in anything that we do, and it is very important to keep an overview on what are the different risks that we encounter in a project that is as challenging from the consortium point of view as it is due to these elements of innovation. First of all, we encounter risks in terms of the technological maturity of what we are doing and of what we are designing. Yes. You can see on the picture of the right one of the first composite parts which was scrapped because of a combination of problems that was related to us not yet controlling the technology for the manufacture of that particular component. It involved from design considerations, which led to the resin inclusions that you can see in this part, to the tooling design, which was not the most the best design which we could have conceived for this particular part, and finally to the layup itself, which being a new technology for us at the beginning, also led to unknowns and to problems on the lamination process. And this led to the scrapping of a few parts at the beginning of the process, as it was completely forecasted when we started doing the whole planning. It is also extremely important, and particularly for a project that is funded by European funds, to keep the schedule under control and to keep the budget under control. The amount of funding that is defined for this type of project is very hardly changed, because the money is not internally spent, is coming out of European funding after a competition has been held, which means that any modifications on this amount and any modifications on the compromises on the schedule will need discussion, evaluation, and approval from the party that is providing the funding, which means the European Commission, which makes it very hard to implement in a project like this. This makes scheduling and budget two very important parts that may significantly compromise the viability of the whole project. I will leave you to Katrin to extend on these management and coordination issues.
Can we please get the next slide? So yeah, there are some facts. I was wondering if you are aware of that only 33% of projects and only 2.5% of companies managing to successfully complete their projects within an initial schedule and budget. And it's even more challenging in a joint research project where you have more than 30 partners spread via Europe. And sometimes, yes, I use the word nerve-wracking because this project sometimes made me sleepless nights, but they were all worth it. There's no doubt about that. But due to so many stakeholders you have and so many unknown things, it easily can happen that something slips out of your mind. I mean, we are just humans, and we are working with humans, and of course, not every time everything works in the 100% way. So the right mix of planning, controlling, and monitoring of the project make, of course, a big difference for a successful completing of a project within the given time and budget. And the key thing here is that you really must have the overall project on your mind at all the times. It doesn't help if a consortium have only their own schedule on their plate without seeing the overall big picture when somebody else have to deliver what and where it's impacted with your part of the project. And as I said, as we are not all in one company sitting at one table in one meeting, this is sometimes, of course, a little bit challenging to have everybody at any point of the project on the same page. Even internally, I would say sometimes it's a challenge to be on the same page on a daily basis. So especially for me, I identified here some issues, I would not call it issues, topics, which were leading to such difficulties sometimes. So we have so many different companies, and of course, all the companies have their own working philosophies, the way they are doing things, the softwares they are using, the procedures internal. The people are thinking differently depending on their mentality, where they are from. So I can see that by myself. I mean, I came from Germany to Romania, and I thought, yeah, I'm in Europe, and I learned that our mentalities are quite different. I mean, there's no I don't want to judge anything that somebody is better or not. It's about we are different. We are just the way of working, the way of thinking, the way of communicating is very different, and you have to overcome language barriers, which could have a real impact. I can just remember last week I said something in the meeting. It sounded so harsh, and I didn't mean it like it sounded. So even I reach sometimes the level of not being so mature in the language I have to challenge, and then you can imagine if you have so many different countries and stakeholders that it's even more challenging than between German and Romanians and Spanish people being involved. So, and of course, the companies may have also a different approach and reasons to join such a project. It's either that they want to develop new technologies or materials, or it's to give their people probably the opportunity to develop their knowledge within a research project. But I would say the approach, for example, between a research institute or a company like Romaero, the approaches for joining such a project are completely different. So here you already also have to tackle this situation to bring mindsets together and understandings, and this is already challenging as daily in the software. It's an issue, if you believe it or not, it's an issue. Software can be a real issue. It's that, for example, not all the people who are working with it are on the same level trained, and that occurs already problems within communication and the expectations also of the others, because you think, what can be so hard? Yeah, because you got a proper training and the other person is new to the project and stuff like that. So these are just some aspects which makes it really challenging all the time within a research project. Can we probably go to the next slide, because I want to point out probably 10 well-known things within management and coordination aspect. I think that's nothing new I'm pointing out here. To keep your team on the same page always, this is key. I hear it really often when I ask the question, are you aware of that? That people may answer, no, I'm not. Nobody told me, I wasn't in this meeting, I wasn't on vacation, and I missed this information. So this is really key. If the left-hand side does not know what the right-hand side does, that's a problem by nature. Defining the goals and the objectives of a project, well known, is key for any project, but for a research project, defining the goal is probably a little bit, so we lost something, okay. So it's probably in the very beginning, very generic, I would call it, and on the way you you just get a clearer picture of what you really are going to do. So the awareness of unrealistic deadlines, what to say about that? I think a lot of projects are facing this problem. You do your work package sheet, you calculate what you estimate what you most likely will need of resources and times to achieve these goals. And yeah, then things are happening, life is happening. And when you have already unrealistic deadlines in your schedule, then this screws up a lot. So that leads me already to the next point, because maybe people think that everybody is using the same project management software. No, this is not the case. So you probably are used to MS Project, and others are using a totally different software, so you can not merge your files and stuff like this. So it's really time consuming, and you lose a lot of positive benefits of using the same project management software. So it's really something I can recommend in any project from the very beginning, to pay attention that you really are on the same page covered here, because this is really, it's incredible how big the impact can be for this. The scope creep, yeah, I think everybody who is dealing with project management is well aware of this wording. This is what you don't want to have in your project, that you get a scope creep. This is the worst case scenario. But yes, many projects are ending up in it, and there are reasons for. The tactic, the value for free strategy, I would call it, is even for very experienced project managers challenging every day. So like these big projects we are in here, yeah, I have this nice picture here. Can you finish that in a month? And the answer is yes, I can fail at any speed you like. So I think this describes a lot what I want to say, probably. So being realistic with everything what you're doing is important. So you need to react quickly to insufficient team skills. This is what I was referring for training your people. If you are within such a project, you might agree on a common software to control your project, for sharing the DMU, the VPM, and if you use a software, for example, where you are pretty used to every day because you work with it, but your partners are not, and they get a sharp training in the very beginning, and maybe the people within these teams are changing, so you see where it's going to, right? So this can really be a bottleneck at one point if you are not able anymore to access this data correct, or to get the correct output of it. So I can just recommend to train your people very well for the needed skills. Yeah, the miscommunication cause conflict. This is sure, as I said not that long time ago, something which caused a conflict nearly. And of course, I realized it whilst the words left my mouth. I realized that was probably not the words I wanted to use. So I tried during the meeting to come back to this point and to correct myself in what I wanted to say. And I think this is really important. Communication is really important. We are working again with humans. Everybody, you don't know what happened today at this person in the morning at home, and you might get him on the wrong feed, and you say something what he usually just takes as normal and granted, and on that day maybe he will take it totally different, in a totally different meaning and manner, and that can of course cause a conflict, and these conflicts do have an impact on your project. So Also, the risk management is crucial. Yes, it is. A risk management, sometimes if people are not used to work in projects, they define a risk when it's already there. So that's not the goal. The goal is in the very beginning to think about where are the risks, where could be the risk on your way, what could be a risk mitigation for it, and to have really a plan B, because when the risk appears, then it's already there. So you can't properly manage something which appears. You just can react on the situation, what is sometimes probably then not the best solution for the situation. Teamwork within such a big project can be very challenging. As I said, we have different mentalities, we have different way of workings, we have different skilled people. We can't, due to the COVID, it's even worse. We can't travel that easy back and forth. So it's for me, it's really different to sit in front of the computer and having a video conference with all the people on the other side, instead of sitting in front of a person and seeing a reaction on what I'm saying. And this is getting harder and harder by video conference for me. So I prefer, of course, to be in the same room with the person. And teamwork could be easily, and I think it's underestimated also by management, it's underestimated, very often could be supported by team events. It doesn't need to be something big. I can just remember the team building event we did. We had an Oktoberfest here in Brasov. We went there with some team members, and it was two years ago, yeah, more than 2 years ago when we did this. And for me personal, and maybe Albert can confirm this, it was really helpful, because you get this moment where you can interact with a person you might see once a day for 10 minutes, but you know nothing about that person. You don't know anything about their interests, if they have family or not. And I think when you work with people, this is a real big aspect in any project, because the better your people are able to talk with each other and to act and interact, the better they solve problems. This is a fact for me. So if you don't know anything about a person, you might be too shy even to go over and say, you know what, I did a mistake, or I have a problem, can you might support and help me? If you know the person, like we both know each other, meanwhile, there's no hesitation anymore to say, you know what, I have an issue, can you probably support me? Or oh damn it, I did a mistake, how can I fix that? So these are little aspects, but when you have plenty of them, it creates a big one. So for me, teamwork and supporting your team with getting each other to know in the beginning, and even spending after work going for a beer, yeah, it's challenging also now. It's not that easy anymore, but yes, some of us are doing this, and I just can say out from my own experience that working with a person you know better is just better. It's simpler, and it's keeping you away from also probably acting differently, which is a matter of reality. And the avoid of lack of accountability. Yeah, what can I say here? Roles and responsibilities, people. This is, I want to have it on my forehead written. Roles and responsibilities are important. If the person in charge of something does not know where his responsibility does start and end, you create by nature already conflicts. It's I mean, it's simple, and even the responsibility you feel as a person is like, it's not clear either to you. And for me, if my role is not clear, I don't feel even comfortable with it. So I prefer to know where my role starts and where does it end, and what it means, because I want to be responsible for what I'm doing and I want to do it good. So if I have the impression that I don't know if I'm okay, or if I'm stepping now on somebody else's feet in doing it, simply that it's done, then you already have a really, really ungood situation, and you really should avoid this. And yes, what nobody probably have seen coming is what happens if the pandemic called COVID appears. So that screws up a lot of things. We have to face many difficulties like everyone else to protect our teams, to stay in working mode. Distancing, social distancing is a keyword here. So it's a matter of space, probably, if all the people can work in the same time in the same office. So what happens if you can't access from home your DMU, for example, in INCAS? We can't do that from home. So the people need physically to come to the office. I can do my job from wherever I am in the world, because I can dial in, but I don't need to access a DMU, for example. So for me, it's pretty simple. But you have this kind of aspect, or in the economical point of view, the crisis, especially in aviation, is huge. So you probably face difficult months, years, nobody knows that yet, and you don't even know in the very beginning when all that started if that will hit you or not, and how hard it will hit you. And I think we are just not over this situation yet, and this impact is probably really not so easy to have under control. So this is one of the things we hardly can control. We try to tackle the problems we are having due to this, and so far I would say we managed it quite well. Within our teams, we were lucky by now so far, and we hope, I knock on wood now, that it keeps remaining like it is and everybody stays healthy. And yeah, so I will give it to Albert now to tell you a bit more about the supply chain outline within the project. Maybe we can get the next slide.
Thank you, Katrin. We are not yet changing subject. You introduced a very relevant topic, which is the pandemic, and it is important to extend on this topic the moment that we talk about supply chain. We are responsible for what it is a small part of the RACER demonstrator. We are only responsible for the center fuselage, and we still have under us a quite significant amount of companies, of suppliers, of service providers, which are helping us, supporting us, or working for us, depending on the case, on making this RACER demonstrator come to life. We are getting raw materials from all over the world. We are getting some components which are offset to other companies to help with the production capability, and because it's their area of expertise, and we're getting them from all over Europe. And we are getting also auxiliary materials and hand tools from everywhere we can find them. And adding to this already difficult mix, the situation with the pandemic right now, I'm not going to venture into the details, because anybody that is working right now in a project that involves more than one company, or even a project that involves a single company, already knows the effects of the situation that we are facing right now. And this just makes all this supplier relationship very difficult at this moment. This translates mostly into worst case scenario, unavailability of things, and in a better case, just an increase of price or an increase of the lead time for some of the equipment, of tools, or parts, which in the end translates into higher expenditure of the project and longer development time of the project, which are the two aspects that we're all the time trying to keep under control. So this is probably a risk that very few people saw coming, and that probably even less people know how to control in a project this size. We are not these people. We are
trying not to
we are trying our best to keep these aspects under control. And in some areas we manage, in some areas we face harder times. So far we cannot complain at all. So far, as Katrin said, we are lucky. And being a very complex project, and being a project that involves a lot of manufacturing, from the manufacturer's point of view, it is extremely hard, if not impossible, to apply social distancing to the effective activities, to effective manufacturing and assembly activities. If you have an activity that is designed for 2 people to be performed, you need those 2 people to perform that activity. If you would be able to make it with 1, then you probably already would be doing it with 1 person. So this is quite challenging right now. Well, I guess I'm not giving any news to anybody. So maybe we can go to the next slide, please. If we were talking about a normal context right now, if we would be able to forget about the pandemic and just focus on the supply chain challenges for this demonstrator, then we would be talking about a set of conditions that make the supply, the purchasing of elements and the procurement of materials for a demonstrator a bit more difficult than for a conventional product that we would later on industrialize and produce in a serial production line. Basically, because we will be most likely facing, as we are in this RACER helicopter, with new suppliers. New suppliers means that we will probably and most likely need a qualification of these suppliers. We will need audits, we will need quality assurance work hours in order to get these new suppliers approved. We will be working, as we mentioned already before, with a design that is going to be frozen very late on the production process. To give you just an order of magnitude of what we are doing in the RACER helicopter, we are 2 months nearing the delivery of the fuselage, and we still have plenty of drawings that are still open. We are still working on plenty of interfaces. We are still working on a few design solutions that are not yet completely frozen, and we are trying to mix all these aspects together into a calendar that exists on the first plate and that is good for the overall project schedule. And this is very challenging. We will be facing a lot of retrofitting even before the fuselage is completed, precisely because we are forced to implement modifications on the design, because we have changes in the requirements, because we have late definition of interfaces, which are going to affect all this schedule and which are going to make all this manufacturing process more complex, and ultimately are going to make all these supply chain processes more lengthy and sometimes even redundant. We then have the problem of the low quantity of required materials. We are not talking about buying simple screws from the shop on the corner. We are talking about getting highly specialized materials. On the composite materials, we're talking about materials that are usually made on demand. We are not talking about materials that we usually find on stock because of the very short shelf life of these projects. It is almost impossible to find the particular specification that you need. on stock at the supplier. It is an amount of luck which the current situation does not really allow for, which means that it is going to be a challenge to go to a supplier, a big supplier such as Toray, such as XL, and ask for 5 square meters of a material that they do not have on stock. They are going to say that the minimum quantity available is 200 square meters, and then you may be forced to buy 200 square meters of a particular amount of material just to manufacture a 10 by 10 centimeter part, which you are not going to be producing anymore for the whole project. And these are challenges that the supply chain poses. We are grateful, and we've been relying a lot in this aspect on the coordinator of this project, on Airbus Helicopters, which, because of its huge composite manufacturing infrastructure and its huge volume of production with materials that are very similar to ours, are able to support in most of the cases on these procurement aspects for composites. Otherwise, we would be forced of making orders that would be 100 times larger than the required quantities, just because the minimum deliverable quantity is what it is. And the supplier is not going to change this rule for a one-off demonstrator. Also, the bargaining capability with the suppliers is completely influenced. There is no way of going to a supplier and negotiate a better price because you're going to be doing purchases later on. You're just buying one-off, and the supplier might just tell you to just go back to where you came from, and we are not bothering to supply you just for the quantity that we are requiring. And this combined with the fact that we face a shortage of local suppliers in Romania for everything that implies composites, makes all these purchasing operations lengthy and costly. It is very important in a project like this to consider these aspects from the beginning, so you do not lose the order of magnitude of the procurement costs at a very early stage of the project already. We are talking also about materials that, as we already mentioned, have a relatively short shelf life, which means that the possibility of buying 100 times more quantity to later on use it on another project is completely unfeasible. This applies to the raw materials, this applies to the standard parts, this applies to the hand tools used for the assembly, and the moment that you combine this non-existence of local suppliers with all this unavailability of materials means that the logistical costs are going to grow exponentially. They are going to explode, and you're going to be facing an amount of transportation and logistical costs that are way bigger sometimes than the cost of the materials itself. And this is very tricky on a project, on a demonstrator with a tight schedule as the RACER is. If we could go to the next slide, please. The transitioning into industrialization, and I want to leave everything, a very important point clear right now. The RACER helicopter, the RACER Rotorcraft, is a demonstrator. There is no industrialization further than the development of the demonstrator. But as we mentioned at the beginning of the presentation, one of the key goals of any research project is developing internal capabilities that allow later on for industrialization. And this is what we want to stress in this slide. In terms of composites manufacturing, the industrialization process is quite streamlined considering the starting point. We start already with a starting point with this RACER demonstrator, which involved a very tight manufacturing schedule, which forced us to a close to industrialization production process as we are right now. We are working in a very streamlined flow for a demonstrator, which means that any transition into industrialization later on is simpler. Of course, we are paying this at a higher price because we do not have time to implement improvements in the production processes that would usually cut costs into a later industrialization phase. We do not have the luxury of doing this in this project because of the tight schedule. And this involves a way higher amount of workforce in this demonstrator phase. If we were talking later on about industrialization, we would most likely be talking about higher volume not only in the production, but in absolutely all the stages of the process. We would be talking about higher volume in storage for materials. We would be talking about higher volume on procurement, which would also make, as we just mentioned, as we would cause the procurement costs to go down by some amount. We are talking also about the volume and of the utilization of the equipment, which means also on the amortization of the equipment, which is a significant element of cost in a development project in which we are starting a production line from scratch. And we also start facing logistics internally as an important factor for the production process. Right now in a demonstrator, we can afford having a forklift, moving everything around and living with it, waiting for half a day to get the forklift from one side of the production process to another. If we are talking about industrialization, we start not having these luxuries, which means that we need to start taking a close look into the internal logistics, into the internal flows in terms of physical flows. And also related to this, we need to start looking into the maintenance of the equipment, not as a collateral that appears one time and causes a struggle and forces us to replan something, but as a scheduled maintenance, as part of the schedule for the manufacturing process. We are not then talking about an equipment that broke. We are talking about an equipment that is down for maintenance every X time and for an Y determined period of time. You can see in the picture the manufacturing of one of the components for the RACER helicopter. And what we wanted to stress in here is the redundancy of the workforce. Right now, at the demonstrator phase, we can afford something that is cheaper and something that is less versatile in terms of production, which is having less people that do more individual things each, and without having an overlapping on the competencies of the different workers. This is one of the elements that is causing now problems. The moment that we're talking about this COVID situation, the moment that we lose one person, that was the person that was an expert on a particular operation. For a demonstrator, it makes sense because we're talking again about low production and about usually longer manufacturing processes. But the moment that we start thinking into industrialization, we need to be able for scheduling 2 shifts, for example, 3 shifts on a production line, which means that we need more than one person expert in each of the different operations. Otherwise, it is impossible to cover the different operations continuously throughout the work week. And last but not least important is to consider the fact, this may not be the case particularly, but it might be relevant to think that some of the activities that were subcontracted for a demonstrator because the equipment was expensive, because the necessary know-how was not enough in that particular area, may be worth doing in-house the moment that we're talking about industrialization. The moment that we start having these aspects under control, then we can start talking about increasing production and increasing the manufacturing volumes, talking into a later on industrialization of the production process. I will let Katrin talk about what we learned in terms of management for this project.
Yes, a lot, every day. So maybe we can, thank you. So yes, where to start? So in the very beginning, everybody was talking about the TRL level 6 within the demonstrator, and I can remember that the understanding of TRL levels are not the same with all the people. So it's a recommendation from my side, as soon as you have a technological project, you should be very clear with all your stakeholders that you have the same understanding of a TRL level. I was surprised that this is happening, but as a matter of fact, it happened. So that's just a really probably important recommendation from my side, that you are really all on the same page what that means. So in our case, TRL 6 means we go into flight testing. And I think this was not very clear down to all the people being involved on all levels, that they had the same understanding of this. The transparency in the planning between the partners and all stakeholders is, as I said from the very beginning, it's very important. It's a key topic. As we are doing the fuselage, we have a lot of interfaces. That means we have a lot of interfaces with other project partners, with other consortium. And yes, of course, it's important for all the stakeholders around to know where we are and where they are. And at one point you need to merge the project. And so you should be very transparent with your planning activities. And if you have a shift to the right, okay, nobody is happy, but you should communicate this as soon as you get the knowledge about it, because it will affect the most of your partners around you. So this is not a one-way direction. It goes into all directions. So it goes from the coordinator to us and vice versa. And it's really, really important. So the clear understanding of the coordinator roles and the project partner roles is important as well. What is the coordinator responsible for, and what you are responsible for as a project partner, and what you have to deliver and at what time to your coordinator. So what we also learned here is batch purchasing is very difficult. So if you wait until a certain stage that you have a complete batch to order, you might have significant delays. So yes, on the other hand, you create more workload if you purchase everything in a single step, and you have probably higher transportation costs. So it's a tricky situation, as Albert already said, to handle this purchasing story until you wait to order your things, to have them in place when you start manufacturing and starting the assembly. Again, I can't say it often enough. The shipment between partners consume a lot of time and resources and budget. And I would say, I personally can say for myself, I have underestimated this a bit. If I look what it takes us now to do shipments for NDT testing, for example, because we don't do that for the composite parts here in Romaero, so it goes a long way to Donauwörth. Then the people need to be available there, and of course nobody is waiting for a part arriving from our side, so they need to schedule this also to implement it in their schedule and to ship the parts back. Then you have a reception, you have a quality check, and so on and so forth. So this is something I personally underestimated. This is why I pointed out. That's for me a clear lessons learned, to have that on my screen as a lessons learned for the next project. And communication, communication, communication. There is never too much of communication. I agree, the scope of the communication should be reduced and clear, and not having a long email written just with some sharp points. It's enough to have your people on the same page, and if they have questions, they should be welcome to be asked. And what leads again to the roles and responsibilities I mentioned earlier, especially with cross-functional teams, this is even more important, to have a clear picture who is dealing with what. And of course, under this aspect, this is now to all the upper management probably, because you need to empower your people. To give a responsibility to a person, but not officially empower them within your teams, within your company, yeah, don't do that. So this is not a good approach. So if you put a responsibility and a role on a person, the role should be clear, the responsibility should be clear, and it should be clearly communicated within the entire project community. Because otherwise you create, on purpose, this is how I call it, on purpose you create difficulties within your teams, and this is something you really don't want. The change management is also a process to learn and to understand the change, to accept the change, and also to adapt it in the future way of working. Just doing change management and nobody understands it and tolerates it, then you have an issue for sure. The close exchange between program and project management is very important. The project manager lives and stands and falls with the program manager and vice versa. Don't underestimate this. You need to have a very clear vision of what you're doing, a common strategy, a common way of communication to have your people on the same page. And this is really important. The skills, I mentioned it, if your team members does not have all the same and all the needed skills, train them. If you don't train them, don't blame them if they fail. Then it's just simply your responsibility. There we are back. So the minutes of meetings, I was fighting for this in the very beginning. I can remember not all the people are used to do this. So for me, minutes of meetings with an action list, with the responsible and the due dates, and the distribution of this, and also the follow-up is for me a very important thing. And I learned within this project that not everybody sees it like that important I see it. And anyway, no matter what you're doing in such a project, it's a wonderful project. It's such a big honor to work within it. Don't play the blame game with your people. We are humans, we are in a research project, we do mistakes, we don't have 100% of performance every day when we are in the job. And instead of looking for the person to blame for something went wrong, I really want to point that out, that I think we are on the same page with this. You should work solution oriented and just avoiding to repeat these mistakes. And I think there are some lessons learned for the technical aspects also from Albert's side. If we can go to the next slide, please.
Yes, just a short wrap up on the technical aspects. We're getting a bit more technical in here on what we learned in terms of design. It is very important to not underestimate the schedule. And the design activities are more ethereal. They tend to lengthen themselves past the point in which you committed yourself to complete the design. The big lesson learned in this project is stick to your design schedule. The moment that you can close your interfaces in time and release what you need to release for manufacturing at the time that you need to release for manufacturing, then later on you will have time to retrofit the parts, and to implement modifications later on. If you are not capable of maintaining your design schedule, then the overall project schedule will start to slip, because then you might find problems in the remanufacturing or the redesign of toolings, in the redesign or remanufacturing of assembly jigs, and this is exponentially increasing the time and exponentially increasing the delay of the project. An important lesson that we learned, and this is why we were happy in the top picture and sad on the lower picture, is that the tooling design process is more important than it seems like for a demonstrator. Even if you are planning on using the tool once, you may end up using it more than once. And it is very important to have good toolings. If you just underestimate this and you do toolings faster because anyway, we're just producing one part and we do not need to spend all that money and we can use cheaper materials because we're just using them once, you end up having to repair the tools, to remanufacture the tools, to remanufacture parts, and in the end, it's never going to pay up. When you are accounting for the risks of that, it is very important to keep this. And in terms of composite manufacturing, I guess that this is not a surprise for anyone. It was a bit of a surprise for us at the beginning. Vacuum is very important, quite important. We experienced a few problems with the vacuum tightness of our tools. This is related to the previous point. So vacuum tightness is the key on the manufacturing process, with prepregs at least. And as long as you have tightness and as long as you do the proper debulkings at the proper stages in your manufacturing process, then you will have the process under control. A last point that we completely underestimated also was the amount of activities that are required after the part is out of the autoclave and has been demolded. And this is a point that actually will stick to our minds afterwards, having a part and working on it for days and days without being able to send it further on into the production process because there were still activities to be done. If we can go to the next slide, please. Just to conclude, we would like to thank you for your attention. We are aware that we exceeded a bit our presentation time. We cannot help but get excited when we are talking about this project. I hope that you like this presentation, and I think that Jim will relay us if you have any questions. We will be more than happy to answer too.
That's very good. Thank you. That was an excellent presentation. There's a lot of lessons provided for all of us to learn there. So with that, we'll go to the questions that were submitted. So we kind of covered this, so I'm going to kind of just ask for a quick recap. How has the COVID-19 affected the overall project and its delivery schedule within the bulk of the rest of the project?
So far, I would say we were, as I said, lucky compared to probably other projects and other companies. In INCAS, I can speak for INCAS, we have the luck that we had enough space to split the teams to different offices, that they don't need to sit in a too small space with each other. We of course installed plexiglass screens between the desks and so on. The sanitizers are around, of course. This was taking, of course, a little bit of time. So our people also have been sometimes working from home or were staying at home due to the situation. And currently, the virus in Romania, especially in Bucharest, is having a big impact. We are at emergency state on a high level again. We have 3 on 1,000 persons being infected. This is a lot. So you can imagine, so schools are closing, parents need to stay home again because of their children. And so yes, you do have an impact on your team, on the people. But somehow so far we could, by luck, probably also manage not to be affected too much.
We were lucky. We were lucky in the project. We had to shut down the sheet metal manufacturing workshop in Romaero about 3 weeks after we had finished the last of the RACER components. That was pure luck. We started. We found some cases in that area, and we had to shut down the workshop. The advantage that we face right now in Romaero is that we are spread over a huge extension, which means that the different workshops are physically quite separated one from another. And still, right now we are working on the premises that the moment that we have one case in a particular section on the company, that company is shut down immediately. We're testing everyone in that area, everybody that was in contact with that particular person. And after that, then we're thinking on reopening. So far, the project has not had significant delays in terms of that, but we are expecting in the short future to start feeling the economical consequences of this exponential growth of the number of cases in the last time. So we will see.
I would say the biggest challenge within this topic was the procurement, in fact. So you had closed borders, you know, your trucks were stucking somewhere on the road, or your material was going to expire because you were waiting for something else and it didn't arrive, and so you had topics like that. But yeah, this was challenging, but you adapt somehow. Somehow we're adapting to it, right? You're getting used to the situation, you're getting used to the social distancing, to wearing your mask all the time, stuff like this. So, but I would still call it, in our case, we had a lot of luck so far. If I look around, and I'm talking a lot to others, I know that they had less luck, and they had a bigger impact. So
yeah, I know it's really raised its head in different ways, and certainly is changing the way we do business, probably for forever.
Yes.
So I guess the next one is, you know, what I'm gonna actually skip down to this last one to start with. If I can figure out how to get it there. So what? When will there's just a multi-part question, so if you want me to stop and we can go back and replay them, I can do that. When will the fuselage be delivered? What was the biggest challenge in its development? How does it compare to conventional fuselage designs, and what makes it so very special?
Okay, let's take it step by step. The delivery of the center fuselage is scheduled for the end of this year. We are working on this scenario, and if the world context allow us, we are planning on keeping this schedule. So this was the first question. The second question, I think it was related to the design of the fuselage. Basically, the fuselage technology itself, as we mentioned in the beginning, is innovative for us as a consortium. The technology considers a hybrid carbon shells with aluminum substructure, and aluminum substructure within, which means that we are facing challenges mostly in terms of electrical compatibility of materials, and in terms of bonding and joining of materials that have very different mechanical properties, but there is no huge element of innovation in that area. We are mostly talking in the RACER helicopter that the primary element of innovation is the architecture. We are working with a helicopter fuselage that, in terms of design and stress, has nothing to do with a conventional helicopter fuselage. We, as you can see in the pictures in the presentation, we have 2 sets of wings. and we have some pusher rotors at each of the wingtips, which introduces stress conditions into the fuselage that are completely different to the stress conditions that you would have in a normal helicopter. This has a lot of implications in the substructure architecture, and of course this translates later on to all the design elements of the helicopter. I don't know if I answered to all the sub questions.
Yep, you did address each of the questions. Yep. So, so I guess the next thing is, you know, throughout the presentation, you highlighted a number of pitfalls that you encountered throughout the project. But I wonder, there must have been a lot of successes too. And be nice to hear what you would highlight as the greatest successes throughout the project.
Well, we did not show a lot of pictures of successes because being a research project and not being our own financed research, we are somehow restricted in most areas in what we can show, we cannot show. This is the reality of our industry. But yes, of course, we had one of the main elements of success 1 month and a half ago, when we managed to manufacture the single largest composite part that I think that we have ever produced in Romania so far, which was the center bottom shell for this helicopter, which was like 4 meters long and 1.5 meters wide. And it was like the part that included everything. The geometry was quite simple in terms that it was almost flat, but it contained everything. It was sandwich, it was monolithic, it contained copper mesh, it contained copper foils, it contained core filler, it contained assembly of mounting plates, of support substructure underneath. There was carbon assembly, there was carbon metallic assembly, there was areas painted, areas not painted. I mean, this was one of the biggest successes. There was a part that we had been sweating for months, and seeing it out of our workshop was definitely one of the highlights of all this project.
It was, by the way, the 24-hour shift Albert and his team did to make that happen. So when you receive at 3 and at 5 a.m. in the morning pictures from the team in the shop floor, then it's really impressive. So I think that tells a lot about the team spirit.
That's mostly.
It's sort of a follow-up to that. You know, what kind of changes would you recommend, if you have any, to future projects? You know, especially for like clean sky type programs. What kind of structural changes would you make to the program or recommend to the programs to help facilitate greater successes and what I'll say, fewer lessons learned?
There is one aspect that is very rigid in European financing, and I think that Katrin will agree with me in here, which is the amount of budget that can be subcontracted. Mm-hmm. This is one of the most rigidly defined elements in all the European research projects, and it's also it's understandable. I mean, the approach is understandable, and the situation is a bit unfair, because most of the times you're presenting a proposal for a project without the full picture on what is the extension of the scope of the work, which means that you might find yourselves later on in a position in which you need to develop something. I mean, the classical, this is not what I signed up for. And you might find some aspects in the project in which you need to develop particular things that, even though they are not the main scope of the project, are relevant to the budget, and you cannot perform in-house. And this, for me at least, maybe you have some other points.
Yeah, I can agree to this. The point in this European research project, I think I don't know the rules in US. So I can only speak for European or even German national funded related topics. In Europe, you don't choose your partners. You have a call, the partners applying, there is a committee having a review on it, and then deciding with which partner you go. So here already you don't have a clear scope of work. You don't have that. You do a statement of work when the project already is in the middle of something, probably because the calls for partners are not all in the same time from the very beginning. So that means it comes an implementation, another implementation, another implementation on the way. And this is really, I would say, one of the challenging topics within a European funded research project, that you don't have this full picture from the very first day. You don't have it. It's simple. So it's nobody's fault. It's still not there. It's the procedure on the way. And I would call this the most biggest challenge to adapt, because how to plan, who is doing what, there we are again, right? So to have a very detailed, organized, structured project from the very first day is nearly impossible.
Mhm.
That is very interesting. That's something that I didn't recognize. So, and if I now look at the clock, I see that we have come to the end of our program for today. So, thank you very much, Katrin and Albert. It's an excellent presentation. There was a lot of great information here, and we appreciate you taking the time out of your day, especially this late in the evening. Although I guess, Albert, this is really just like the start of your day. So we appreciate you taking the time and sharing the information. We'll have this posted up on our YouTube site here shortly. And I thank our attendees for joining in today and asking some good questions. And we'll leave it at that, and we'll catch you on our next presentation. Just for those that are still listening, we have 3 more presentations this week, 3 chapter meetings. So you're welcome to join us, and Katrin and Albert, you're also welcome to come join those as well. Although they would be like for your breakfast break for a couple of them. So with that, I'll ask Chris to go ahead and send us away, and we'll say goodbye. So thank you again for your presentation and your support for BFS. Thank you.
Thanks for having us.
Thank you.